Bismillahirrahmanirrahim. Okey, selamat pagi. Kita kali ini untuk for today's session we're gonna begin chapter 9. Chapter 9. Chapter 9 ni kita ada dua bahagian. 9.1 ni on system design, architecture design. Satu lagi bahagian nanti kita sambung waktu tutorial waktu tutorial tu nanti kita akan sambung dengan kuliah sikit sebab dia tak berapa banyak. Yang ini banyak sikit slide dia. Dan kita akan bincang projek lah jika ada apa-apa pertanyaan dan discussion based on progress waktu tutorial nanti. Alright, and as for today, I hope you all already click your attendance. While we begin our lecture. So take about probably 1 hour, if not less. So kita begin lah. So saya tak pasti buku kamu ada e-book ke tidak, tapi saya ada e-book on Tilly. So saya tak pasti kamu, sebab kalau ikutkan buku tu yang kamu bagi waktu course info dalam course information. So kalau merujuk pada e-book System Analysis and Design tu on author by Tilly, dia based on chapter 10. Chapter topic 9 kita ni dia based on chapter 10, so boleh refer chapter 10. Alright, so we begin with our topic 9.1. The first part of the topic, architecture design based on system design. So what is basically architectural design? The content for today's lecture is, of course, what is planning architecture, bila masa kita buat planning untuk sistem architecture ni. Dan basically yang lain tu client server architecture, internet based architecture, probably some what we call it, some revision lah, sebab saya percaya dalam classes seperti ITT400, apa lagi, a little bit on CSC443 pun mungkin ada bincang on system architecture ni Sekejap ya. Sorry ada gangguan. Okay, so this is basically our SDLC our system life cycle, yang mana kita dah cover masa peringkat awal SDLC System Analysis and Design, where we get our specification through requirement fasa requirements, and of course we also have at this phase, this phase is requirements, requirement engineering process, yang mana pada peringkat ini kita collect and gather informations regarding what are the keperluan, what are the requirements that system want. So bukan setakat business process saja kita capture, kita juga capture antara lainnya keperluan bagaimana sistem yang klien nak tu akan dibangunkan dan akan digunakan nanti. Sama ada mereka nak dalam struktur standalone ke, ataupun mereka nak dalam architecture networking base ke, ataupun internet base ke, ataupun distributed base ke. So pada peringkat ini kita dah tahu dah apa keperluan klien tu So bukanlah benda yang di fasa kemudian baru kita identify. It's actually been identified at the early stage. Why? Because this is what we have to ask, what are the things that the client wants when the system is ready. So system macam mana yang client nak, so kita actually gather at the early stage. So basically this shows, if you look at the slide, this is the level requirements engineering, yang mana this at the specification phase. Specification is basically the output, yeah. So kalau kita buat feasibility study, so we will get the feasibility report. So that is the first document. Kalau kita pakai waterfall model, definitely all the documentation kita kena hasilkan before we go to the next phase, kan? Tapi kalau kita guna iterative, kalau spiral tu they have dia masih lagi ada banyak extensive documentations. Kalau dah start prototyping, dia dah start less documentation. Probably the most important documents are the user requirements and system requirements. Yeah. So kalau kat sini banyaklah dia punya requirements documentation yang kita kena hasilkan. So the documentation is basically, we said, has specification. Yeah. So we have the feasibility report, and then system models, user and system requirements. So dia akan hasilkan kumpul ataupun put in a different parts, what we call it, the requirement documentations. Okay. So dalam bila kita pergi ke next phase-nya, which is designed and then implementation, there's a bridge antara design and implementation. So the bridge tu is actually a lot of communication phase antara system analyst dengan programmer. So salah satunya mereka akan bridging, transferring what the system analyst understood for the system to the programmer. Sometimes like macam big company, dia dah specifickan job specification tu very specific. Kalau macam big company, kalau untuk programmer pun dia asingkan those who yang manage database dengan those yang buat programming. Tapi kalau medium size software house, usually a lot of the staff ataupun the IT staff buat 2-3 job spec. Tapi paling what we call it, the job segregations tu antara system analyst dengan programmer. Okay. So pada fasa design and implementation, the bridging antara system analyst dengan programmer itu sangat-sangat penting lah, the communication. So that's why we refer a lot on the system requirement documentation. Okay, so that is the basis of communications between analyst, system analyst dengan programmer. Okay, so itulah fasa di mana kita develop the executable software system. So bila kita develop the executable software system, there's also another part included, which is unit testing. Sebab programmer, once you develop the coding, definitely you need to do some unit testing. Unit testing tu antara programmers dengan coding lah. So design is an activity to identify software component, has been done by the system analyst. System analyst, I will identify the relationships based on the customer requirements. So implementations of the process of realizing the design has program will be done by programmers. And this is a creative process depending on the years and experience that the programmers have, how well they use the code, whether they reuse the code or simplify the code. So kalau develop system using what we call it, old coding system, definitely the lines of codes is going to be very long. So the newest code language dia dah banyak simplify, especially kalau kamu guna OOP lah. Banyak embedded features yang telah dimasukkan, so you tinggal apply. Yeah. So that is based on experience as well lah. So then that is on the development phase lah. So dalam development phase ni, the bridging between the design and development, basically dia ada 3 bahagian, which is software design process dengan physical design. So the software design process is also what we call as logical design. Yang mana secara model dia, jelas kamu dengar suara saya ni? We have the design input. For the design input, we got all the documentations that we need. So inilah platform information yang kita dapat, information berkenaan dengan sistem architecture, bagaimana yang kita nak sistem tu nanti akan terhasil, akan digunakan. Specification requirement ni ada documents yang kita ambil, gather during requirement engineering. So data description ni dia specific. Dia specific yang mana dia also part of the system requirements, sebab bila masa kita cakap pasal DFD ke, business process management model ke, definitely the process flow must embedded together with data description. And then dalam process flow tu kita identify which data yang kita akan store, which data yang kita akan manipulate, and apa yang kita expect on data derive, data yang kita expect akan dihasilkan oleh sistem based on data processing or data manipulation. That is data description. Tapi at this level dia masih lagi dalam peringkat description. Okay. And then we go to the design activity. Now this is a bit extensive on analysis. So we have the architecture design where we got the input from platform information, and then we got the interface design. Dulu interface design ni kamu akan belajar HCI, tapi tak ada dah kod HCI tu dalam program 2 CS 264. And then ISP550 pun saya tak berapa pasti topik HCI. It's not really that extensive. Supposedly we also discuss quite extensive on interface design because it's part of system analysis punya job spec dalam masa bila kita buat requirement engineering tu, kita dah tahu macam mana sistem interface design yang client nak. And then component design. Now component design ni pada saya sangat-sangat penting dan dia mesti di-practice seawal mungkin. Kalau next semester kamu dah part 5 kan, so kamu akan buat sistem, kamu dah start dengan project proposal, and then seterusnya project development nanti masa part 6. Component design is very important. Apa yang kamu faham tentang component design ni is basically how you structure overall of your, how you structure secara overall sistem kamu tu. Okay, contohnya e-commerce. Dalam component design e-commerce, dia mesti ada contohnya user authentication, yang mana most of the user ni must authenticate before using the platform. Second, dia mesti ada sistem cataloging, ataupun item cataloging, and then and shopping cart. The third one is the payment, and the fourth one is delivery information. Contohnya delivery information. So that is your component design. So dalam payment, contohnya dalam payment model menu tu ataupun dalam komponen payment tu, so dalam komponen payment tu ada lagi selection types of payment kan, and then methods of payment, payment handling contohnya. So dia ada lagi pecahan. So kalau dalam method of payments tu mungkin nak bayar secara online, secara online banking, ataupun menggunakan e-wallet. So that is how you put all of the component and its subcomponents in your organization. Sebab the functionality and the non-functionality of the components berkait banyak dengan how well you structure it. So lagi senang lah nak manage macam tu. Tapi selalunya kita lupa bahagian komponen design ni. So kalau kamu dah nampak komponen kamu dan how well you structure, then I can see that you have a good mind. Good mind in organising the process flow. Sebab komponen design pun nanti dia akan banyak berkaitan dengan database design. Dia akan berkait juga dengan interface design. So itu masih lagi daripada peringkat logical. Peringkat logical ni, maksud peringkat logical ni, kita contohnya macam database design ni kan, kita tak fikir lagi data type dia apa. Kita tak fikir lagi data type dia, kita tak fikir lagi sizes of the data type dia contohnya. Dan probably we tak fikir lagi to make it private or want to make it public. Contohnya lah, that is on the logical. Logical and conceptual lah. So the first part is conceptual, then we detail down, kita jadikan dia logical. Dan yang kat bawah ni design output ni, this is the physical design. So meaning kita dah start specify, kita dah specifikan kalau sistem architecture tu, kita nak kata contohnya kalau networking, kita pakai untuk WAN katakan, wide area network contohnya. Ataupun kita nak pakai LAN sahaja, local area network. Kita dah specific. Okay. So database specification, kita dah set dia punya data type, kita dah set dia punya method. Kita dah set dia punya sizes, kita dah put restriction, and so on so forth. Okay. And so as well interface specification and component specification. So this is the descriptions on what's the difference between logical and physical designs, because some system developer dia akan tengok, tunjuk saya bahagian logical design kamu. Maksudnya dia tak nak tengok bahagian detail lah, dia tak nak tengok bahagian table yang mana kamu list down all of the data types, sizes, restriction, method and so on so forth. Dia nak tengok kamu punya ERD je contoh, atau nak tengok kamu punya class diagram saja contoh. Okay, so logical design make no reference, kita tak fikir lagi ataupun kita tak akan kita really focus on the relationship first. No reference made to any technical environment, capable of implementations on a variety of platforms. So maksudnya model logical design kita tu, kita tak fikir lagi dia punya technicality. So bila katakanlah in the future kita nak replicate the logical design, kita boleh. Nanti kita akan tukarlah dia punya physical design sahaja. So that's why a lot of logical design we reuse, made reuse for or apa tu yang sebelum tu, based on our experience sebelum tu. System analyst dia ada pengalaman macam tu lah. So it's more on the act as a model of how on the system will satisfy the user requirement. Reflect underlying business rules and activities rather than physical constraint. So it's like a blueprint, because it's a contract, kita punya logical design is a type of contract juga. So that contract tu mesti kena ada blueprint dia, so that the in between the developer dengan client tu, kita mesti find an agreement on how the system going to develop based on what the client want. So this is basically a contract as well. So the physical design ni pula, now we go further detail lah. So yang ini banyak pengalaman ataupun banyak bahagian programmer, dia akan communicate lah dengan system analyst on how dia nak tentukan the physical aspect of the system development. Yeah. So the logical design translated into a physical design based on the technical environment selected, yeah, such as platform, programming language, database. So the programming language usually bergantung kepada the expertise of the software house. Kalau software house tu expert in using a certain programming language, they are professed ataupun profoundly good good at certain programming language, usually they will use that programming language, yeah, including its database. Sebab they probably have the license already, yeah? They already have the skill, the training skill set for that particular languages. Okay. So it also produces program specification, physical files, or database definitions, and user interfaces for a selected target hardware and software. So kita dah start thinking about the technical environment in which types of architecture models yang kita akan pakai. Ya, kalau LAN, how the logical or the physical environment tu akan memenuhi the LAN network punya environment, ya, katakan. Kalau online, dia akan penuhi online. So nanti dia akan tengoklah the architecture untuk e-commerce, katakan kita kena pakai yang mana. Tak bolehlah kita pakai LAN kan, for e-commerce memang tak sesuai. Yeah. In fact, wide area network pun tak sesuai. So which type of architecture model kita nak pakai. Yeah, so we start then kita akan tengoklah specification secara teknikalnya on database design. Kita start naming the database, kita start naming of course the database. The database tu kita akan create dah table-table dia, naming the table, relationship of the table, the data type on each items tu dah ada data types dia, on each item tu dah ada sizes dia dengan method dia yang kita allow. And then we also have the output design. Dari segi of course reportings, communications, dari segi functionality, kalau ada macam notification, request approval or rejected, and some logical lah sense dia, logic programmings dia, yeah. And then we also have the program design, structure of programs to collect, transform and how. Ni maksudnya bagaimana kita push and pull somehow between the programmings, the coding dengan relationship between database, and then tengok on system architecture design. So dia dah start detail lah. Macam saya kata tadi lah, kalau nak pakai e-commerce, nak develop, dia tak boleh pakai, dia kena client server punya system architecture lah. So architecture design process ni kita set daripada early stage masa kita collect the requirement bersama dengan client. So dia is represent the link between specification and design process and also the physical mode lah tadi. Often carry out in parallel with some specification activities. Dia akan dibawa bersama. Sebelum ni kita banyak belajar on bahagian component design. Tapi sebenarnya dia bersama, dia parallel. Yang antara dibincangkan ialah the architecture design. So it's part of our requirement bersama klien lah ya. So it involves identifying major system component and their communication. So dalam pada kita, dalam komponen design kita tu, kita mesti cater sekali bagaimana communication, contohnya message, functionality macam verification. Sometimes kita nak verify guna email kan, second step verification tu kita nak verify guna email ke. So structure dia macam mana, architecture design dia macam mana. proses dia macam mana lah for that particular physical punya activity, ataupun kita nak pakai handphone punya verification, pakai OTP katakan, ataupun pakai SMS katakan so dia dah consider juga bahagian architecture design. Architectural representations is basically a simple informal block diagram showing entities and relationships are the most frequently used method for documenting software architecture. So cara kita nak describe ataupun nak show the architectural representation is using simple informal block diagrams. Block diagrams ni macam kamu buat common visualization lah, sama ada nak pakai block diagram pakai gambar user, squares, arrows, and probably to show some boundaries, another box for boundaries. So that is any methods that will able you to explain back to the user, and of course as a form of communication between the system analyst dengan programmer. But this has been criticized because the lack of semantics, of course lah. It's simple, so basically understood lah. Sebab it's a system developer punya part. Untuk user kita akan simplify seboleh mungkin untuk mereka faham how it works. But the working part is more on the developer's part lah. Alright, so gonna look use of architecture model, of course, is a way to facilitating discussion about the system design. So the discussion between the developers and users and among developers team members as well. For example, macam tadi, system analyst dengan programmers. In fact, programmers dengan programmers, probably kalau sistem tu terlalu besar, you need a team of programmers. So some programmers focus on certain components, and some programmers is on actually focus on the data component. Kalau big company usually macam tu, tapi selalunya software house they punya sizes is medium size kan, so programmers is dia ada overlap job spec lah so you boleh baca lah kat sini so basically it's a form of discussion. You have to present back balik pada client, this is how it's going to look like, this is how it's going to work. They understand how it works. Why? Because they are the one who bagi cost kan, they are the stakeholders, they are the users, so basically they need to know how it works. Ini contoh lah. So this is architecture design. Ni masih lagi peringkat logical lah yang ini contohnya untuk sistem high level, peringkat high level maksudnya masih logical lah. Kalau high level tu dia masih peringkat conceptual sebenarnya. Masih lagi peringkat conceptual. So dalam architecture design ni apa yang ada? So basically we identify the major components of the system and their interactions. So organize the components according to an architecture pattern, such as here high level of a weather station software. Kita ada contoh untuk sistem weather station software. This is where example where they use the communication link for networking, yang mana dia orang ada komponen seperti fault manager, configuration manager, power manager, instrumentations, data collections and communications, and it link through this communication link. So this is the example of a high level architecture design. Itu yang dikata simple block diagram. So yang penting client kita will able to understand. They don't need to know lah the communication link ni what, but then kita cakap lah, we're going to use LAN for example, for local area lah kita akan pakai LAN. So what is a LAN? LAN is a internal networking system. So kita akan pakai kabel jenis apa. So it's just a brief description. Okay, so yang ini dah start logical. It's a generic antara generic layered architecture dengan sebelah kanan tu contoh. The generic layer architecture tu dia terbahagi kepada 4 layer. The upper part tu is the front part. The lower part tu is basically the end part, the back end part. So the upper layer tu usually kita ada user interface. Daripada user interface kita ada user interface management, and where used for authentication and authorization. And then kita pergi ke layer paling bawah, core business logic dia ataupun application functionality. So basically it's mana business logic kita, process flow kita, algo kita, is actually at this level. And plus we have the system utilities, dan paling bawah sekali is the system support, such as what types of OS kita support ataupun databases apa yang kita pakai. So that is the layer. Saya tak pasti kamu, is this the first time kamu jumpa ni ke tidak, ataupun dalam kelas ITT400 kamu pernah jumpa ke tidak, saya pun tak pasti. Tapi these are the generic layer of architecture, especially current one lah. The above 1995 punya system development punya method. So sebelah kanan tu contoh Lipsys system is a library system. Library system whereby the user interface tu is the web browser interface. So maybe here you can support any types of browser page lah, interface. And then dekat bahagian user interface management tu kita ada Lipsys login. Login tu for authentication and authorization. Then kita ada component for forms and query manager, and kita ada component for print manager. So dekat bahagian bawah tu is based on logic, business logic and functionality dia. For example, we have the distributed search for searching punya activity, documentation retrieval, how we take from the user request daripada web browser tu ataupun query manager ni, take from the database and give back to the user. Okay, and the library index. Library index is part of the categorizations on the database lah. So database ni kita ada banyak database, for example. So dia ada banyak lah database yang disimpankan. So ni example. So planning architecture ni okay, system architecture translate the logical design into physical structure. Includes hardware, software, network and processing method. So architecture design is a broad design of overall system structure, also called has general design and conceptual design. So planning architecture ni involves 3 main functions, which are data storage and access method. 2 application programs to handle the processing logic, where you have your logic, algo, restriction or constraint, and the third one, an interface that allow user to interact with the system. So such as search function, security function. So these are the 3 main functions what we consider for planning architecture. So the 3 functions are performed on basically a client and a server, and the third one divided between the server and the client. Yang ini adalah dia punya dari segi loading, kat mana you nak bagi dia lebih for functionality, sama ada you nak loadkan dia banyak dekat client side or you nak loadkan dia banyak dekat server side. So both ada the advantage and disadvantage dia lah. So paling client server ni saya rasa it's not first time you hear lah. Definitely masa ITT400 kamu pernah dengar. I think kamu belajar apa lagi? ISP400 lah. Paling definitely you heard about it. So server ni is, patutnya kamu dah tahulah apa server tu at this stage. So server is a high-end computer lah. A server is definitely high-end, high processor types of computer that supplies data, processing services or other supports of computer. So kalau OS tu, kalau software tu, kalau dekat server side, you have to install the server side kind of installation. Zaman dulu ni mainframe, I think kamu tak pernah lah experience mainframe ya. Saya sekejap je lah experience mainframe masa study dulu. So mainframe, dia akan panggil mainframe dengan terminals. Yang mana terminals ni dia cuma ada input and output device je. Dia tak ada processing sebab processing semua dekat mainframe. Ini zaman dululah. Paling latest sekarang ni ataupun paling common is the client server architecture. So client server architecture, sebelum sampai client server architecture tu kita ada LAN, kita ada WAN kan, networking architecture. Tapi most commonly because we have the internet right now, definitely lah we have the client server architecture. At this rate, sepatutnya kamu tak ada pemahaman kamu on client server tu dah adalah basic betul kan? ISP400 dah belajar, dekat CSC443 ada belajar sikit tak on this? Dah belajar ke belum? Ada tak diberi some sort of input untuk CSC443? Kau tengah belajar kan semester ni? Sekejap dia semua, dengar ke?
Dengar madam.
Tengah belajar. Are you guys okay? Hopefully okay tu.
Okay madam.
Okay. Kenapa saya tak dengar Alright, kalau tulis caption pun tak apa Alright, so basically we have a client, we have a server and we divide between client dengan server. Okay, system that divide processing between one or more network clients and a central server. So client handles the entire user interface including data entry, data query and screen presentation logic. Server stores the data and provide data access and database management function. Alright, so there are the communications between server and server and client. So description, so kalau kita pakai client server architecture ni, the functionality of the system is organized into services. So bila sampai peringkat ini, the term functionality tu kita akan ubah jadi a service. Okay. So kalau functionality tu kalau merujuk ke komponen tu pula service functionality component. So nanti kalau antara most common kita panggil system maintenance dia akan tanya service mana. So kalau peringkat yang ini peringkat sampai peringkat sekarang ni dan dia akan jadi service pula. So dia akan ubahlah sikit term tu. Into services which each service delivered from a separate server. Clients are users of those services and access servers to make them use. So clients are considered users for the services. Okay, so clients are allowed to access the service based on the services that they want. Okay. So when used when data in a shared database has to be accessed from a range of locations. because servers can be replicated, may also be used in the load in the system is variable. Maksudnya kalau dalam selalunya database we put in the server. So database can also be replicated or mirrored. So that's why kalau lagi banyak mirrored database, so the loading factor dari segi loading loading flow atau loading proses antara klien dengan server tu akan ikut jarak lah. So kalau jarak tu jauh, lagi besar ataupun lagi banyak klien, so it is advisable ada mirrored server Contoh kalau dalam building pun, katakanlah 3-4 offices nak guna printing services, whereby the printing services hanya located dekat level 3 for example. So the whole building tu is linked to the printing services. Right? So disadvantage dia biasalah kita ada DOS attack DOS attack, denial of service attack or server failure. Server failure tu termasuk dua jenis lah. Sama ada server failures because of accessibility, whereby the loading management tu, the loads management tu problem, so you must consider a higher level kind of server, ataupun total failure sebabkan probably kilat ke, kebakaran ke, that is physical punya failure. Alright. So this is an example of a client server design style where you have the server has a database server, right? The server has a transaction server, the server has an object server, dan juga the server has a web server. Okay, the database server antara server dengan client, apa yang do transfer, exchange is client transmit SQL command for query. Server transmit results on SQL execution. So based on the query, the database server will process the query. Perlu join tak table, apa yang client nak tu based on what, reporting, what types of reporting, so on and so forth. So dia akan based on SQL punya language. So that's why SQL is a very important language for you to learn. So kena mahir lah. Transaction server, apa yang apa yang di-communicatekan antara client dan server ni, for when server has transaction server, client triggers transactions. Transaction ni, any transaction is from when you have transfer and input and expected and output. Termasuklah payment, termasuklah verification, termasuklah messaging. So that is what we call transaction. Okay. Where ada movement antara client ke server ke client. So that is transaction. Any transactions of information or process triggered in the system. So the server executes sets of SQL commands and verifies results. Object server, client client object messages. So server object messages. So web server dengan client transmit internet communication, so the server juga replies internet, that internet communication, and or vice versa. Alright, so basically that is the rough idea. So ini contohlah client server architecture for a film library. Film library. Film library ni online film library lah kan. So for example here you have the internet has the medium of your accessibility. And then you have these services, yeah, services, and it can be accessed by clients. So client is represented as up here, yeah, client 1, 2, 3, or until N, where in the services first you have the catalog server, where you can view or look at the library catalogs, what films do they have, and then you can access the video server by requesting the videos, yeah, or picture server by requesting the photo that already stored in the database, or the web server. Ni pembahagian server lah. Sorry, the services ni based on film is very heavy. Data on film is very heavy, so dia boleh pecahkan according to the server, different server. Ya, nanti bila ada request from this server ni, dia akan communicate and start transmitting to the client. So bila sampai dekat client, nanti akanlah ada bahagian dia yang akan kumpul semua balik, and then akan keluarlah filem seperti mana yang ditonton itulah ya. So kalau dalam contohnya katalog server ni disimpan the library, katalog library, because information banyak kan. Video server saja dia kena specific video server and so on and so forth. Okay, now another terms that you're going to learn today is fat and thin client. So what does it mean by fat and thin clients? Fat client ni is also known as thick client. Design locates all or most of the application processing logic at the client. Okay, so thin client, design locates all or most of the processing logic at the server. So that's what it terms, the fat client and thin clients. Kalau fat clients tu dia kena high end lah sikit, dia kena high end lah processor dia. So costly lah. It depends on the system that you gonna do. Kalau e-commerce usually thin client lah, sebab most of the processing logic is at the server. Tapi kalau contohnya kalau dekat client tu kamu kena do some sort of analysis ke, you nak train the data ke, you nak running the data ke, then you have to have fat client. So depends on the purpose of the system. So these are the advantages, the characteristic of fat client and thin client in sense of network traffic, performance, initial cost, maintenance cost, and ease of development. Okay. So kalau e-commerce definitely kata it's a thin client kan. So we look at the network traffic. Network traffic, definitely fat client is higher because the loading issue lah, accessibility to the server and also the loading issue lah. Performance slower because more network traffic is required. Initial cost is higher because more powerful hardware. Maintenance cost is higher because when you have powerful hardware, you have higher maintenance costs. And in fact, the environment for that client also kena consider. Server ni kan, kalau saya tak tahulah sebab dulu saya pernah saya rajin bawa student pergi visit database center, server center kan, dekat Terengganu ni pun. Saya ada bawa student pergi UMT tengok dia orang punya database server kan. Usually bahagian hardware untuk server dia memang sejuk memang kena cap sejuk. Sebab cannot heat nanti dia akan tak boleh panas lah, dia kena sejuk. So I'm not sure about fat clients ni, tapi dia kena high end. So high end processor definitely dia tak boleh panas lah. And then ease of development. Tapi ease of development is easier because system are resembled traditional file server design where all the processing was performed at the clients. So the file server design tu dia banyak dekat client. So yang ni pun saya tak sure lah. saya kurang ada pengalaman kat sini tapi untuk thin client ni more difficult lah, sebab kamu kena imagine ataupun kamu kena consider bahagian clients, and then must optimize the divisioning between the server and the client side, especially on the processing logic. Dari segi dia punya logic coding dia dekat server tu. So that's why kita pakai banyak scripting lah. Hari ni scripting to support JavaScript ke VB script ke. Tapi untuk development FYP usually kamu, itulah sayangnya tak ada pengalaman untuk kamu install virtual server kan. So basically kalau most of your seniors for FYP, laptop dia akan dijadikan client dan akan dijadikan sebagai server fake server lah. Alright, for thin client, the network traffic is lower, performance is much faster, initial cost is much lower. Nanti boleh kamu tengoklah slide ni nanti Okay, so kita tengok client tiers. Saya rasa, saya tak pasti kamu pernah dengar pasal client tiers ke tidak. Tiers ke tiers ke, tapi saya think the pronounce is tiers. The most common tiers is actually we have the 2 tiers design and the 3 tiers design. 2 tiers design when you have the client and server initially, where the user interface resides on the client, all the data resides on the server, and the application logic can run either on the server or the client. It can be divided between the client and server. But this is, kita dah tak pakai banyak dah. Kalau web server nowadays, paling basic is 3 tier. The 3 tier design where the user interface runs on the client and the data is stored in the server, where we have the middle layer between the client and the server that processes the client's request. So the 3 tier is the most common nowadays. Kalau 2 tiers zaman dulu lah, where the application logics are shared, tapi masa tu mungkin functionality tak se-advance. Now internet dah ada, so the application logics dia dah makin banyak so it must be supported by the middle application server ni. So the internet based architecture yang ini ialah macam kamu belajar dalam ISP550 the entire user interface is provided by the web server in forms of HTML coded documents that are interpreted and displayed by the client's browser. It simplifies the process of data transmission, results in lower hardware cost and complexity. So internet-based architecture ni salah satu contohnya ialah cloud computing. Kita ada distributed computing. Cloud computing ni bila mana kita ada banyak server nodes and it can be accessed by banyak client nodes. Countless client nodes. So cloud computing ni dia ada banyak clients lah yang resides. So remote computers that provide a total online software and data environment that is hosted by third parties. Third parties ni is another parties lah. So it effectively eliminates compatibility issues. So it doesn't care what types of OS you use. So it eliminates that as well, or what types of browser that you use. Scaling on demands requires significantly more on bandwidth. So ini yang kita pakai banyak sekarang ni, like macam Google, like macam dulu Dropbox. Dulu saya pakai Dropbox lah. Sekarang Google is very ni apa lagi yang ada cloud. Banyak lah OneDrive, OneDrive, Google, itu yang biasa kita pakai lah sebab itu yang organisasi bagi kat kita Okay, 2 web 2 ni apa bezanya web 2 dengan 1. So web, kalau 1995, e-commerce dah start 1995 dekat Malaysia tu e-commerce start blooming tahun 1999, 1999. Probably 97 tu dah start. Blooming bila 1995 tu kita dah start internet but masa tu e-commerce very limited functionality but dikatakan web 2.0 ni sebab kita ada social media tu yang kita jadi web 2.0 yang mana kita banyak guna AI AI logics logics lah to use to connect and reconnect between one networks to another, one person to another. Macam Facebook, ResearchGate, LinkedIn, so dia akan keluar je recommended je dekat kamu, your new friend because his friend to your friend, his friend to your friend before, kan? So because of that we have 2.0. Tapi memang dengan web 2.0 ni banyak dia punya triggered like business intelligence, business analytics, trend patterns, behavior patterns. So dia banyak dah start mula on behavioral punya factors, not only functionality but also behavioral. So nanti besok in the futures kita hanya jumpa di alam maya saja. Look at the gaming trend, making friends trend, TikTok. You live in the internet. Wow. I cannot imagine how real you are compare how real you are on the internet. So that is web point tu lah. Alright, itu lain isu lah Tapi basically that is web 2.0. Next is repository issue. Repository architecture is basically for database. Database, data warehouse. If you use data warehouse, tapi most common is the database. Shared data is held at the central database. So database is located at the server side. Or another name for database is repository. And may be accessed by all subsystems. When a large amounts of data are used to be shared, the repository models of sharing is most commonly used as this an efficient data sharing mechanism. Okay, so this is an example for a repository for architecture for an integrated design environment. Integrated design environment is a software tools for system development lah, for modeling system. Contohnya NetBeans, Eclipse, so dia very extensive lah. So kita ada, for example here, these are the all subsystem. So subsystem ni ada yang bahagian editor, bahagian generator dan juga translator and analyzer. So they're very comprehensive. Tapi saya rasa saya tak tahu kamu guna ke tidak Eclipse atau NetBeans ataupun yang seangkatan dengan dia. So processing methods ni basically kalau kamu belajar e-commerce, you will understand this methods. There are two types of processing methods, which are online processing ataupun batch processing. Online processing ni based on online lah request, real time, handle transaction when directly to the user. So this is contohnya ATM query process ataupun kamu buat online transaction through Shopee ke Lazada is a real time processing. What is batch? Online processing characteristic. System process transaction completely when and where they are occurs. Users interact directly with the information system. User can access data randomly. The information system must be available whenever necessary to support business functions. So that is online. So e-commerce usually online. Example lah, this is example Asia. Batch processing ni macam misalnya credit card, kita akan do batch processing or billing such as phone bills, electrical bills, where kita akan collected according dia the time dia, dan dia akan proses ikut batches. So selalunya batch processing used for large amounts of data that must be processed on a routine schedule such as paychecks or credit card transactions. The IT operation groups can run batch programs on the predetermined schedules without user involvement during regular business hours, at nights or on the weekend. It requires significantly fewer network resources than online system. So batch processing antaranya ialah credit cards ataupun sistem cuti ke AIMS pun sometimes pakai. Sistem AIM yang kita pakai sekarang ni pun batch processing. That's why kadang-kadang apa yang perubahan berlaku dekat jadual tu ditunggu dulu certain hours. Dia akan batch kan according to hours. Sometimes you can do it batch by days, sometimes in a month. Selalunya kalau benda hari dia akan buat middle of the month to next middle of the month. Atau you can do by days or by week, or you can do by hours, batch by hours, processing by hours. So you can set the batch processing. Bila ada banyak request, dia akan tunggu dulu, kumpul, and then baru dia run. Depends on the management of the system and the nature of the system. So it will dia akan selalunya sistem akan compare lah which one. Sebab kalau kita nak buat request online every time, mungkin tak se-effektif kalau kita kumpulkan dan kita proses dia according to batch. So dia ada effective issue lah. So yang ni kita akan fikir masa dari segi, kita akan identify masa loading, masa integration phase, which is the best methods, dan tengok what are the method of processing yang kita akan pakai which is more effective. Ini contoh a combine of online and batch processing. Antaranya ialah contoh point of sale. Point of sale processing ni macam kita beli online dekat kaunter, kita bayar lah kan, macam warehouse, Giant ke, Maiden ke, kan dia ada banyak kaunter pembayaran kan, sampai berbelas-belas, probably 20s. Katakanlah bayangkanlah semua counters tu buka, then what happen kan. So point of sales is once the item swipe into the system, dia akan affected dia akan update dalam database. So the update is immediately. Tapi the calculations of sales for that day, probably it will generate by 10 o'clock at night contohnya. Once the counter tutup dekat pukul 9.30 katakan, pukul 10 baru dia run for the sales report, contohnya. For the sales, total sales for 2 days. For 2 days punya activity. So dalam POS ni dia banyak lah dia punya sebab dia antara yang paling awal dan rentetan seterusnya. Banyak dia punya information to contribute to inventory, sales, lagi accounting and so on so forth. So dia ada banyak ni inventories based on items. So bila inventories tu items tu mungkin dah out of stock. So kalau out of stock nak kena restock. Is it done automatically ataupun perlu human punya management? So by probably staff bahagian inventory by 9 o'clock tengok sales mana yang paling banyak habis pada waktu tu, then they have to restock and so on so forth. And then next to the sales transaction, dia akan tengoklah total sales for today. Total sale tu boleh pula bagi bahagian item, boleh pula bahagian total. Lepas tu pergi pula bahagian accounting, who's working, who's not working on that particular batch. Katakanlah ada mistake dekat counter sekian-sekian ni kan, ada tak pembetulan of that corrections yang dibuat oleh staff salah counting and so on and so forth. So basically that is the combined online batch and batch processing. Network model ni network model ni yang kamu dah belajar masa ITT400, the 7 layers tu ya. OSI, Open Source Integration Interaction, OSI, the 7 layers. Yang ni revision lah. Nanti kamu tengok sikit lah. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Yang kamu dah belajar masa ITT400. So network topology ni pun dalam ITT400 saya rasa kamu dah belajar. Kita ada network server. Network topology ni hierarchical network. Hierarchical network. Yang kita refresh sikit lah. Hierarchical network, bus network, ring network. That's it. Alright. So basically that is, sejam lebih juga So basically that is what we've learned today in architecture design lah for this part. Nanti kita akan sambung untuk second part, topik 9.2 sekejap masa tutorial, dan kita akan sambung dengan discussion on tutorials. Alright, ada soalan ke? Ataupun saya stop recording, so kita boleh tukar mode lah, tukar mode. Ada soalan ke? Tak ada ya? Okay, kalau tak ada, we end the session. Thank you very much. Alright, kita end the session. Sekejap. Alright.